Yesterday we understood what is RAG and why do we need it, but I've received the feedback that it was more of a theoretical video and I should explain it with an example, making it more practical. So let's do that in this particular video. Now we know that LLMs are trained on data and there is cutoff date for each LLM up to which it was trained on, the data up to which it was trained on, right? So let's say I want to ask it yesterday who won a cricket match. It won't know about it because it doesn't know about that data yet. Now, the same situation is faced in enterprise data or some private data that I might have, and LLM does not have access to it. If I try to ask questions about that data to the LLM, it will hallucinate or it will give me incorrect answers. To fix that, we can use RAG. What we'll do in RAG is we'll provide the context of my private data or my enterprise data to the LLM so that it knows what I'm talking about and then it will be able to correctly answer that particular question. So let's understand what a RAG architecture would look like. RAG architecture will have two parts to it. One is indexing. So indexing is a prerequisite, like whatever data, whatever documents we have, we convert it to text format and then we load it into our vector database. So these terms that I'll be talking about, vector databases, embeddings, we'll understand them in detail in future videos. For now, just understand that our documents are in text format. Computer won't be able to understand, LLM won't be able to understand the meaning within those words, within those sentences. So to make it understand, what we do is we convert our documents, our text to vectors. Vectors is something that LLM can understand, and then we store it in a vector database. This is the indexing part that we do. Now, once the indexing is done, then comes retrieval and augmented generation. So what we do is we send the user query to the vector store, to the vector database, and we find similar sort of text from that particular vector database. Now, once we have similar text, once we run a similarity search from vector DB, we get some context, we get some text which is related to our questions. It may or may not contain the answer, but it contains the context on which LLM can answer our query. So we send that particular query, we send that particular context to the LLM, based on which LLM will be able to generate answers from it. So this is what a simple RAG architecture would look like. Now let's see a practical example of it, right? So we have done a bunch of imports here. Then we created an LLM object. Now I took a resume and I loaded it up in a document and then I converted into raw text, right? Next comes text splitter part. We'll understand why do we need text splitter. We'll understand why do we need embeddings and how do we load it into vector database in future videos, but this is exactly what it is, what's happening here. We are splitting our documents into chunks and then we are storing them into a vector database. In this particular, it is files. Next part is augmented generation, where we created a chain. Don't worry about too much about what is load QA chain, why are we creating it. We'll understand all of those in future videos. For now, just understand that from the resume, we want to ask a particular question. What are the core technical skills of this particular candidate? So we mentioned that as question, and then we passed that to the chain and we got a response, right? So what you need to understand is we did not send the entire document to the LLM. What we did was we ran a similarity search on our database, on our vector database based on the query that we have, and we received some related text which we stored in docs. And then we passed our query and docs to the LLM, and then we received a response. So in this particular case, we received that core technical skills are this. Additionally, user is also proficient in the following languages, tools, and technologies. That's what we were looking for. So this is what a RAG example looks like. We'll understand this going forward. That's it for this video. Thank you for watching. Have a good day.